So welcome to this session of Webcast Wednesday. My name is Jagrati and today we're going to be talking about the various cluster operations in LabVIEW, and we're also going to be discussing the various display formats within LabVIEW such as graphs, charts, XY graphs and mixed signal graphs. So last week we took up array manipulation in LabVIEW and very simple data logging, and as a logical sequence we thought why not cover clusters as well. So now let us learn a little bit about clusters. So this is our agenda for today. I'm going to be talking about some fundamentals of cluster, and then we're going to go on to a very basic question of what the difference between a cluster and an array is. And then we are going to go on to the various cluster manipulation functions in LabVIEW with numerous demonstrations to explain them. And then finally I'll show you how to plot data, plot a single plot or multiple plots on the various display formats, and we'll go on to that in the last part of this presentation. Okay, so most of you probably know what a cluster is. Clusters are used when you have different data types, when you want to group different data types and work on them together. So those of you who are familiar with text-based programming languages will know that clusters are similar to record or struct in text-based languages. So let's just look at this picture on the bottom. Now you don't have to go into details, but let me just show you what it means. So here on the left is just a LabVIEW front panel representation of a cluster. Within it we have three different data types. So we have numeric right here, we have Boolean, and we have string. And on the block diagram it looks something like this, a pink color icon. And when on using this operation called Unbundle by name, you can extract all these elements individually. Now we will go on to learn what these are. So when we use clusters, if you're going to be working with different data types, but all of them pretty much working towards the same application, then you'll go on to use clusters. And also just look at this picture on the bottom. Imagine using 5 different controls and indicators on your block diagram, which will go on to unnecessarily clutter your block diagram. Instead, you can simply wire all these controls into a cluster, which would look much neater as shown on the picture on the right. Okay, so the next fundamental question, what is the difference between arrays and clusters? I'm sure most of you have already guessed it by now or know it by now that arrays is a combination of similar data types, and clusters is used when you have different data types all working towards the same purpose. To put it in points, clusters have mixed data types and arrays have only one data type. Clusters are always fixed size, unlike arrays that we saw last week, how you could programmatically change the sizes of an array. You cannot do that with a cluster. Clusters are always of fixed sizes. Now clusters, just like array, can be a control, an indicator or a constant, but one cluster can only be either a control or an indicator or a constant. So some very basic concepts in using clusters. We will go on to see all of this in LabVIEW. First on how to create cluster controls and constants. And then we're going to learn what ordering of clusters mean, what ordering of elements within a cluster actually means. And we're going to learn what auto sizing in cluster means. So let's go on to LabVIEW so I can demonstrate all of this for you. So this is my front panel and block diagram. Now let me show you how to create a cluster. It is very simple, very similar to how arrays are created. So I'll simply go to this array cluster option and I will go to the cluster option here and I'll place a cluster shell. So this is called a cluster shell. Within this I can place numerous different data types. So I'm going to choose a numeric, a Boolean and a string. So this is my cluster, which consists of 3 different data types, and on the block diagram you see this shows up just as one simple icon, one pink color icon. Now let me just create another cluster and I will convert this into an indicator. So you see I can simply wire these 2 clusters and any change I make here will be demonstrated in my output cluster. So this is a simple input and an output cluster. Now let's go on to see what order in a cluster actually means. So let me go on to create another cluster. I'll use the cluster shell to do this. And I'm going to place the same elements, but initially I placed a numeric, then a boolean, and then I went on to place a string. But now I'm going to slightly change it. I'm going to first place a numeric control, and then I'm going to place a string, and then a boolean. Okay, so it looks the same, but just the order in which I placed it are different. So now if I try to connect this input cluster to this output cluster, I will immediately get an error which reads that I have connected two different clusters. Now though these two clusters look the same, the order in which I placed the elements were different, which causes this error. So how do I change this? I don't want to create another cluster. How do I change this cluster to be connected to this cluster? I will do something called reordering the elements in the cluster. So this option right here, by right clicking on this, shows reorder controls in a cluster. So now when I click this, you see this shows the order. This is 0 because I placed this first. This is 1 because I placed this second, and this is 2 because I placed this third. So let me change this to 1 and this to 2. So I simply have to click here. So now I've changed to 0, 1 and 2. When I'm convinced about the ordering, I'll just click it right here. And now you see this is connected to this output cluster because I've changed it such that this numeric is connected to this boolean is connected to this, and this string is connected to this. So now when I run it, let me change this as well. Now when I run it, the values are indicated. So this is about reordering the elements in a cluster, and you should always ensure that the elements in your cluster always are in a logical order, such that the input and the output clusters, the data types are same. The order of the data types are same. Now let's go on to see what auto sizing means. So when you see I've used a lot of additional space here, which is not really required. So now when I right click this and I say auto sizing, size to fit, it changes exactly to fit all the three elements. Similarly, I can change it to fit horizontally. So everything will be arranged in a horizontal fashion, just so that it consumes lesser space on your front panel. Okay, so now let's go on to our presentation and learn a little more about clusters. So these are some of the very common cluster manipulation functions. You must have noticed this on your block diagram by right clicking on a block diagram and going to this option called clusters. So there are some operations here lesser than those in arrays. Let us see what these operations are. You have probably noticed something called unbundle by name and just unbundle, bundle by name and just bundle, build cluster array, cluster to array, and array to cluster functions. So let's just see what all of these mean. Unbundle operation, as the name suggests, is meant when you want to extract individual elements of your cluster. So your cluster, say, has 3 different elements of 3 different data types. If you want to extract them individually, then you will use something called an unbundle operation. Now, unbundle operation again comes in 2 types. There's unbundle by name and there's just unbundle. So like you can see in this picture, when you say unbundle by name, the name associated with that element inside the cluster will be displayed right here. If you choose not to unbundle, just the data type will be displayed here. So this is an array of DBL is all it displays. It does not talk about the name. So you will typically use an unbundle function when there is no name present on that element inside the cluster. If there is a name, then you can always use an unbundle by name operation. So let me just show this to you in LabVIEW. So this is the one, I just created it already. So you see, this is the operation that we have observed in our presentation. So here it takes 2 points. This is simply plotting a graph, a polynomial graph. So these are my inputs 2, 3, and 4. Now you see this output, this pink color, is actually a cluster. and I'll use two different operations. This is an unbundle by name and this is an unbundle operation. Now you see that this operation, the second operation, does not have a name. Therefore, I cannot use this operation to extract both the elements. The only one with a name is the P of A. This operation, on the other hand, I can extract both of them. I can extract the data points and I can extract the P of A. But in this one, I can only extract the P of A because within the cluster here, only P of A was given a name. This was not given a name. Okay, now let's see when to use bundle, when to use unbundle. So you'll typically use a bundle and unbundle operation together when you want to modify a current cluster. So the same cluster that we took up in the previous example, so this is a plot by samples. So here, if I want to play around with just the P of A values, then I'll extract the P of A values and I'll send this to a filter and I'll send it back to a function called bundle by name. And when I get the output of this, this is a new cluster where the P of A has been modified. Now, if I want to modify both the X and the Y data points, then again I'll use only an unbundle because the X points do not have a name. So I'll use just an unbundle operation. Here I want to increment my X values by 1 and I want to put a filter on my Y values. And now when I unbundle this, and you're always supposed to provide a reference of the previous cluster. So here I'm providing a reference of the previous cluster. So this simply means that I am using the same cluster, just that I'm manually modifying the parameters within it by first extracting them individually and then bundling them back again here. So output of this is again a cluster, just that the values have been modified as per the ones shown here. So you can also programmatically create a cluster on the block diagram where you don't have to give a reference. You just want to create a fresh cluster on the block diagram. Here again you will use something called a bundle operation. So this is my bundle operation and I'm creating a cluster with two different data types, a numeric and a Boolean. So the output of this will be a cluster with a numeric and a Boolean. So that is when you will go on to use a bundle function. You can use this individually on the block diagram as well. So let's just see the same thing in LabVIEW. This is my previous example. Let me build a fresh cluster. I've already built a cluster, so let me just use this previous one that we used. Okay, so this is an input cluster that I have right here. And this is my output cluster. So now what I want to do is I don't want to extract all the data points of this cluster. I just want to extract the numeric out of this, make some changes to this, and then feed it to this cluster. So what I would do here is I'll go to my cluster palette. Let me pin it right here. Then I will choose unbundle by name. Now when I give this cluster to unbundle by name, all the three elements within my cluster show up. So I have a numeric, a Boolean, and a string within this cluster. So they show up right here. Now I want to manipulate just the numeric value, so I will leave it at it. So say I just want to amplify it by 10. Okay. Now I want to feed it back to this cluster. Now I cannot directly give it to this cluster because this is just a single data point. I need to use another function called bundle. So now I have unbundled it to extract one element. Now I want to bundle it back to this cluster. So I will give the reference of this cluster. So, and now when I give it to this output cluster and run it, only the numeric value is amplified by 10. Similarly, let's see how we can build a cluster just programmatically from your block diagram. So like I mentioned, use your bundle by name. Here I can give it, say, 2 different constants. Let me create a cluster of a numeric and a Boolean. Now this is my okay. So previously I'd used something called unbundle by name. Now these two constants don't have a name, so that is why it was showing up that error. But now I've replaced it by just a bundle. Now I'll get an indicator with my numeric and my Boolean. So this is how you can programmatically create a cluster on your block diagram. Now, how do you think this is different from an array? Now say I had a cluster. Say I had a cluster with 3 numeric values and an array with 3 numeric values. Okay. Now how they would be different is, in order to reference the array with 3 numeric values, I will have to use a number called the index, like we saw previously. So it's a number of 0, 1, 2, 3 and so on. But if I want to reference an element in the cluster, when I go on to use this operation called unbundle by name, this is directly going to give me the names of the elements within the cluster. So if I have 3 numbers, numeric 1, numeric 2 and numeric 3, I can directly reference them by the name and not the index. So that way a cluster gives an advantage over an array if you're using similar data types. Okay, now let's go on to understand some of the plots in LabVIEW. You must have seen these plots in LabVIEW. So we're going to take up 3 very common plots. They call graphs, charts, and XY graphs. And I will also very briefly explain what a mixed signal graph is. So these are the typically used plots within LabVIEW. We have a waveform graph, chart, XY graph, and a mixed signal graph. So waveform graph is one that accepts or it plots only array values at once, and it assumes them to be evenly sampled, and it always starts by default at 0 and the sample spacing is 1. A chart, on the other hand, can display single data points at a constant rate, so you can actually see them incrementing one at a time. And a chart also has an additional operation, an additional function of storing data points. You can always see the history of data points, and you can add any number of points to this history option in a chart. XY graph, on the other hand, unlike a graph and chart which uses a constant, the x-axis is constant, that is you cannot change that, it's a constant rate. But on an XY graph, it gives you the flexibility to change the x and the y axis. So you're not just giving the amplitude values, you can also give the x-axis, that is the time axis, can also be manipulated by you. And a mixed signal graph is such that in one graph you can display analog, digital data, waveform graphs, XY graphs. You can have all kinds of graphs in one graph, in a mixed signal graph. I'll go on to show you demos on all of this so you can better understand these. So let's just go back to LabVIEW. Okay, so now first thing that I'm going to show you is how to create graphs, charts and XY graphs, and also how to create multiple plots of graphs, charts and XY graphs. So since I want to show you graphs, charts and XY graphs, I'm going to start with a tab control on my front panel so that I can show you all the 3. So this is a tab control which lets you better put all the controls and indicators on your front panel in a more compact and concise way. Okay, so now first I want to go on to show you how a waveform graph can be plotted. So let me use a simple for loop. Now last week we saw how we could create an array out of a for loop. I want to create a sine and a cos. This is my sine, so I want to plot sine values and cos values. Now these two functions, as the description here mentions, they only take inputs in radians. So that means I have to create radians here. So let me just get a constant of pi so I can convert it into a radian. So I'm converting my degrees to radians here. Let this run for about 500 samples. Okay, now I'm going to give this to my sine and cos. So like we saw last week, to create a graph, to create an array programmatically, you can simply wire this to the border of your for loop, and this auto indexes it, thereby giving an output of arrays, all data points for every iteration of the sine value. Now if I create, say, a graph, let me create two graphs so I show you the sine and cos separately. This is my sine graph and this is my cos graph. So let's just run this and see. So this seems to be working fine. Now I want to create multi-plots of these two, and I'm going to be using a function that we learned last week called build array. Now to create multiple plots in one graph, use an operation called build array, to which you give the two different arrays. This is array 1, which consists of sine values, and this is second array, which consists of cosine values. So let us have another graph here, which shows us the multi-plot of these two. This is my third graph. And then output this, when I run it, I see two different plots given by two different colors. Now you can change the colors of these plots as per your convenience. You can use the property nodes in order to do this, that we have covered in one of our webcasts in the past. Okay, so this is about plotting multiple graphs. So like I said, graph always accepts an array of values. So this is an array of values which is being passed to the graph. It plots the array of values at once. So it is plotting 0 to 500, all the 500 data points at once, because I have mentioned 500 as the number of iterations for this for loop. Okay, now let's go on to understand how the similar thing can be done for a chart. So let me just simply copy paste this here, and I'll get the same input. Now the only difference is, like I said, a graph can plot single data point at a constant rate. So let's also add this. Okay, that means I don't need an array of values. Let me delete this. And let's go on to the next tab here, so I can show you the graph operations. Now the chart operations. Now this is my first chart, second chart, and I also want to show you multi-plot, so let's have 3. Okay, so this is my first chart. I don't have to place it outside my for loop. I can simply place it inside and see the values varying. Let me give it a small weight so that we can see the values varying. Let's give it about 10 milliseconds. Let's change it to 500. So now you see the values varying. This is my sine and this is my cos. So let me just drag this down and place this right here. Okay, so this I will change it to. So I'm manually changing because I want to see only 500 data points. So now we see the values being updated. You see, this is my sine and this is my cos. 500 data points. Okay, now I want to see multiple plots of this. So unlike a waveform graph for multiple plots, we use something called the bundle operation here. So bundle, like we learned, creates a cluster of two different elements. So here I'm creating a cluster of two data points. And to this I will add my last waveform chart. So let's just run this and see. Now I have two different plots, one sine and the other cosine being plotted here. So the difference between a graph and a chart would be, in order to see multiple plots on a chart, I will use a bundle operation. A bundle operation creates a cluster. So this brown wire that you see here is a cluster of two DBL elements, which are being constantly updated during every iteration for 500 data points. So this is as simple as it to create multiple plots on a graph and a chart. Now I said we're going to learn something about something called XY graph, where you can manipulate not just your y-axis but your x as well. So here your x is constant, 0 to 500, because I have mentioned 500 iterations. So it's a constant rate, and so is it in the case of a graph. But in an XY graph you can change both of them. So what we can do is, again, just copy this. So I want to create an XY graph. Same thing. So this is an array of values and this is an array of values. In order to plot an XY graph, the input to an XY graph, first let me just create an XY graph. This is where you find an XY graph. This is the option. Place it right here. So the input to an XY graph is always a cluster of two different arrays. The first array being the Y and the second array being the X. So this is my first array. So how do I cannot directly Y this here, right? Because this accepts a cluster and this is an array. So I can do something to convert this into a cluster. I will use something called a bundle operation, which we learnt about. So I will bundle this and this. This I will give it to my XY graph. Now let us see. So this is showing up an error. Let's see what the error is. Okay, it's not wired. So let's wire this. Okay, so now what should we be expecting in this XY graph? First we have a sine and then we have a cosine. And sine and cosine, there's a phase lag of 90 degrees, which means I should get a circle. This being my sine and this being my cosine. So this is one plot in an XY graph. I would like you to think how we can plot a multi-plot on an XY graph. So this is one plot where I have a sine and cosine value. Now I want to plot, say, a line, a straight line. How do I plot a straight line? Two plots on one XY graph. So now we've had sine and cos. Now let's just use some random number for the sake of convenience, just to demonstrate. So now I will use a random number. So if I'm on a straight line, my x and y need to be the same. So I'll use the same number for my x and my y. So let me just take this right here. Just right here. So this creates an array of x values. This is an array of y values. And both the values are same because I'm using one random number generator. When x and y values are same, we should be expecting a straight line. Now how do I feed this to this XY graph? I have one cluster here. I will create another cluster for these two values. Write it right here and here. Now I have two clusters. If I had two XY graphs, I would get two different plots. But how do I give this value, this cluster value and this cluster value to this XY graph? I'll use something called a build array function. So what does that do? It creates an array of two clusters. So when I use a build array function, where the first option is the first cluster, this is the next cluster. So now if I see the output of this array, this will be an array of clusters. It will be an array of two clusters. This I can very comfortably wire it to my XY graph. So now what should I expect? My graph varies from -1 to 1, and I have given random numbers. Random numbers starts from 0 to 1. That means random numbers do not go towards the negative. So I can always expect a straight line starting from say 0, 0, 0. So now when I run this, I see two different plots. I see a straight line starting from 0, 0, 0, going up to 1, 1. So it's as simple as this to plot a multi-plot graph, multi-plot chart, and a multi-plot XY graph. So based on your application, you will choose the most suitable. So let's go back. So this was about today's session. Now we have our interesting announcement about NI Days. Those of you who don't know about NI Days is a platform that brings together engineers and scientists from India, Russia, and Arabia to discuss a spectrum of applications and technologies and discussing how software-defined systems really are affecting and changing the way we perform measurements. And this NI Days, we have a very special guest with us. We have Dr. James Trushard, and you will get an opportunity to meet him and get a certificate personally signed by Dr. T, as he's called. So we will be choosing top 5 based on this month's contests. We will be choosing top 5 contestants, and all 5 of you will get a chance to come to the Webcast Wednesday zone or represent the Webcast Wednesday zone at the exhibition floor during NI Days 2013. And the top participant will also receive a certificate signed by Dr. T. So winner of last week is Mr. Bakiraj, and I would also like to mention a couple of others: Ahmad, Rahul, Shweta, Sagar, Himanshu, Manivannan, Mr. Prashant, Amori, Ganesha, Parth, and Sebastian. So all of you deserve a special mention for creating such a congenial environment in the Webcast Wednesday community by discussing and giving amazing feedbacks to each other. So let's see the contest of this week. So contest of this week, we have 2 different questions, and you are free to choose whichever question suits you or whichever question you are more comfortable doing. So the first question that we have is for you to build an application form based on name, age, and university or company. So what we want you to do is we want you to create a cluster of all these different parameters, and you're free to add more if you want to. Then using a state machine architecture, you can check for validity of each of these, such that name should not consist of alphabets and special characters, age should be a double-digit number, or a single or double-digit number, and based on the age, there should be either the university or the company option highlighted. So if your age is less than 20, ask for the university name. If it's more than that, ask for the company name. And finally, display your complete applications, and you're free to use any sort of creativity in creating this application form. And do use shift registers to pass the clusters after every iteration. And like we discussed today, use the bundle and unbundle operation to extract all these elements of name, age, and university on different conditions in your state machine architecture. So this is the first contest, and those of you who are comfortable can go on to do this. And we have another alternate question for this week. So what we want you to do is try displaying the first 3 to 5 alphabets of your name on an XY graph. You could try using colors, and when you go on to use colors, you will have to use multiple plots. So to whichever question you're more comfortable with, and we look forward to your participation on the community. So an extended discussion after every Webcast Wednesday session occurs on the LabVIEW enabled community, which is an NI India Arabia community. So here you can get all your queries from the sessions answered. If you haven't understood any concept today, feel free to ask us right there, and interact with your peers and industry experts. And those of you winning contests will get up to 50% discount in CLAD, and attend 20 sessions of this, and you will get a free attempt at CLAD. So this is how you can reach us. Go to www.labviewenable.in. On the top left, you find the Webcast Wednesday icon on the top left. Click on that, and that directly takes you to the Webcast Wednesday page on the community. Thank you so much for attending this session of Webcast Wednesday. If you have any questions, you can ask us now. Also, the link to the question is being posted on your chat window. You can click on that and directly go to your contest and try solving the question.